Hi everyone. Let me turn my mic down. Hello, hello. Hello, hello, hello. Okay, today I want to talk about MIDI and what I've brought together for the MIDI implementation. So let's get right into it. There's two dependencies that I've brought into the project that are related to MIDI, and one is called RT MIDI. And RT MIDI allows us to have this multi-platform native MIDI thing going on for us. So basically we will be able to detect what MIDI devices are attached to the computer, and we can open their ports. The other thing that I brought into the project was an API to actually parse the MIDI messages, because RT MIDI in itself would only give you the bytes, but it wouldn't actually do the parsing of the bytes. So what I'm using for that is libjdk MIDI, and I should show the websites. So let me open up my browser. I really just want to open up all that crap. So okay, we got RT MIDI. We've This is something I didn't use, but it's available. Oh, not use. And the JDK MIDI, which there's a newer one on GitHub. I'll talk about that right now. So JDK MIDI, it's apparently can do a lot of things, but I'm just using it for the MIDI parsing. And it's also available in Java. I'm using the C++ library, of course. And here's a GitHub repository that I initially didn't even know existed. I was using this Google Code, and the Google Code repository is apparently quite old, if I recall correctly. So the last update, oh no, this is the wiki, but it says updated 2006. How can I see? I want to see how recent the SVN was updated. Yeah, I don't know how do I do that, guys, in SVN? Well, I'm just going to assume that it's older than this one, which is on GitHub. Um, this one, has commits up to a year ago. Hmm. So I'm staying away from this for now because I got the older one already situated in, and I mean it's MIDI parsing. How much better can you make it? So, but I did want to make this apparent that there's this apparent newer version. So there's that, and I made a test program to combine the two and test them, which I should really put on my GitHub right now. It's like in a temp directory on my desktop. And what I do is I was making this class called MIDI that was started in the GME project. I call it GMA, but I mean the STD project. And yeah, I'm calling it that. It's not funny, but it is called STD. So SNES Tracker Debugger. And yeah, I called it that. So basically, what I did was I cut the class down from the version I had in STD, and then I just have this simple main where I create this class, an instance of the class, and then just loop. And what happens is that in the actual constructor, a port will be allocated. Just allocates the first port available, and then I get the actual in my so with RT MIDI you have a callback function, or you can also do a queue, but I'm using a callback function. It's multi-threaded that way, if I'm pretty sure about that. So what what I basically do is I write the raw byte to standard out, and by doing that, I can run the program and pipe it over the command line to the JDK MIDI parsing test app. So this was like the first thing I did when I was experimenting with this stuff. I wanted to see if how it looked, how it worked. I'd never used this stuff before. I'm talking about JDK MIDI. So what I would do is I made this little guy. So this would run. I'm using the same makefile from my STD project, so I would just put up an STD executable, and then I would pipe it into where I had my JDK MIDI test parse, which is a JDK MIDI test like example program. So let me show you how that runs. I'm gonna plug in my MIDI device, which is really a DAW with a MIDI capability on it. Turn on my MIDI keyboard. And then what I do is I always use this app to make sure that I'm connected properly. And you can do Apple II, and you can go to this menu and you can test the setup. And you see how it's not working? So if it doesn't work, I'll do rescan and then test again. And there it is, it's working. And that's a tip for whenever you disconnect your driver or your device and then reconnect it. For me, I have this problem, so I always have to rescan after I disconnect it and reconnect it after the first time. The initial time it will work. So now that I've got my MIDI stuff set up, I can run this test app. But before I run it, I really want to migrate it into the GitHub repository, so let me do that. I'm hoping to kind of migrate everything. It's going to be temporary directory locations. I have this feeling that things are going to be changing in the short future. But what I'm going to do right now is I'm going to go to PC Tracker. And everything's just going in here right now. Kind of ironic. And I'll put in a folder. We're basically going to take this temp folder. And then I'll just call it the RT MIDI libjdk MIDI test. And in here, the run script is going to have to be changed. So the run test is going to have to be this is going to have to be changed to // GME VSPC. I could make a link in there, but no. / like libjdk MIDI, I think. Yeah. So that should work. Now if we actually open this up in a console, for you to get the real handle of this stuff, it would have been beneficial for you to see how the RT MIDI worked. But I already told you all it did was take in the raw bytes and then output them. And I've already made so much progress on the initial RT MIDI example that I don't really have anything to show you. But you can just imagine all of these bytes just coming in. So like when I did a note on, the 3 bytes would come in, and you just have them. But so you basically have the gist of it. Watch what happens when we run this test, though. It will be much more clear, and that's what I like about it. So STD here. Oh no, I don't want to run STD. I want to do the run test. Okay, so now I can hit. I just noted on. And so you see how much clearer this is. It just kind of takes the raw bytes here and it organizes them into the components of the bytes. For instance, we got the channel number that it was on, what it is, the note velocity, and the note number. So that's why I brought this library in, so I can have all this information organized for me, and I wouldn't have to write this library from scratch. And MIDI's been around for ages. I don't know exactly, 20, 30 years, maybe 40. So I knew I could find a library that just parsed this stuff for me, and this is one that's working out. So it really makes things simplified too when you're actually programming, because I got a lot of nice little functions, like accessor functions and stuff. For instance, if I look in my code base, where's my MIDI? There's a part here where I can just say, for instance, if it's a note on. So I have a MIDI message, and I can just say, is it a note on message, and do some further parsing, like, get note. It's so simple, right? And probably get velocity equivalent. If it's a program change, I can just get the program change value. So it's nice to be able to code in that higher level, simplified manner. And that's that. And this is how it actually works in the final product. I'll get out of the test app. Should really add that test app while we're here. And I will git add RT MIDI. Now if we go to the GME, this should really be called something else at this point. But I can run the STD. I like Kirby's Dream Course. So I've added another functionality in here, which you can see how it says MIDI port set to 0. Is I've worked with SDL and learned how to open up a preferences path, which SDL takes care of me. If it uses my company name and my product name, which I kind of just made this up. I don't have an official company called Black Hole Studios, but if you're from BAPA, I was on the IRC channel, and we kind of made this together. We were listening to a song, and I felt like I was being sucked into a black hole. And then one of my friends on Pop was like, "You should call your company Black Hole Studios," and I kind of am now. So, yeah, I figured out a way to have this preferences file, and we can actually open up this folder. Wait, what? Something's up. The files. What? Oh, I see the problem. It's the space. If it's not in quotes, you need to add a backslash. So yeah, I have this preferences.ini file. We can open it up, and literally right now it's just a MIDI port and number, and this gets all parsed. So that's how that happened, and that'll allow you to eventually, if you had multiple devices that were capable of MIDI, you could just specify a default, and then SNES Tracker would remember that. And I used to work on this game called Meatball, and I was actually able to take the code for parsing a preferences file and kind of adapt it to SNES Tracker, so that was nice. Now, this stuff right here is part of the MIDI class instantiation. So it just says, okay, yeah, we're using an OSX input API. There's one MIDI input source available. Here it is, my Personas Firebox. Now, all this crap right here is, ever since I had to start including the core audio framework or whatever. Let's look at the makefile. Core audio and the core foundation. Oh, both of them. So ever since I included them, they started spewing out these error messages, which have nothing to do with my app. It's more like a core audio framework problem that doesn't really seem to do anything. Really, I don't know what this is, but it doesn't really cause any problems. I don't know if anyone has any information on this, but I'm not really bothering about learning it myself. Doesn't seem to do anything. So anyway, now what I can do is I've actually added some more stuff besides MIDI, even though this is a very MIDI-centric video. Another thing that I haven't shown you guys is that now you can actually right-click. I don't know if I've shown you this. I may have. And then you can solo a sample, which apparently that sample isn't being played right now. So let's try it again. So this sample right here, we can see exactly what voices are using it. But it's a little shoddy, because if you notice, sometimes after the samples haven't been used for a while, they'll go dim, and the voices will still be soloed. And there's kind of like this failure of communication to the end user, because the truth is that those voices are no longer using that sample, but you still have them soloed and you're under the impression that they are. So that could be a further improvement to be made in the future, maybe. But that's kind of tough one, because with the SPCs, a lot of them go back and forth between different samples, because they're trying to consolidate the channel. So since there's only 8 channels, they're trying to get the most out of them by using different samples in the same channel. So I don't know. I think I might just leave it like that. But the point is that it's cool to be able to identify a sample that is being played to the voice, and then after that, like for instance, we hear this, we can actually play the sample, and that goes and automatically sets the voice. It automatically sets it at the octave 4, which is actually, the recorded pitch of the sample. Um, and that's for like all trackers. C4 is the base pitch of where the sample is recorded at. But now, I had previously shown that you could use your PC keyboard to play, but now you can use your MIDI keyboard, and I'm going to do that right now. So, and I can switch the octave from my MIDI keyboard, which I'll do right now. You don't see the octave get changed here, because this is more like that's more like for the PC keyboard. My MIDI keyboard is capable of actually sending MIDI notes at the full pitch range. So when I change my octave on my keyboard, it'll actually just send the MIDI messages of the lower pitches that were an octave down. I don't have to change that in my software. So it seems to be responding pretty well, right? But there is some issues there. And when you're playing faster, with the way I currently have it, there's this discrepancy where, I'm actually, to get this functionality, I actually have to stop, like pause the SPC player, which is really the Blog's APU emulator. And of course, if the program was playing and I didn't stop it, it would just continuously overwrite the DSP registers, which I'm trying to access. So what I do is I stop the program, I rewrite at the current PC, I rewrite the opcodes with an infinite loop, and that way the program can still be run, but it won't modify any DSP registers. Then I can use what I've done to the APU, which is I've opened up the internal API to write to the DSP registers, and I can actually, if I press a note on my keyboard, I can send the corresponding key on DSP register value on the appropriate voice to the DSP. And then I key off when I release. The only problem is there is a type of like lag, which I am only able to make the assumption at this point that the lag is associated with the fact that I'm using this external API that I've opened up to do all of the interaction with the SPC, in contrast towards the traditional form of communicating with the SPC, which is through an actual SPC assembly program. So I'm going to demonstrate right now. My MIDI keyboard is capable of doing the arpeggiator, and I can set the rate to very fast, and we'll see how it's not synced, it's not rhythmic, it's not correct. And there's 2 things that I'm narrowing it down to, but first let me just play it. So I'm setting it to a high rate. I'll set it slow first. Something's up. It's not working. Hold on. Oh, I have to turn. So I'm using a Nordly 2X. I have to turn on the arpeggiator to MIDI function. So let me do that. If I can find it. Got it. Okay, I just turned it on. Let's see what happens. Turn the rate down. Let me turn that octave down. So you can see how it's really messed up. Let's show how it should really sound by going out of this instrument window so that my MIDI isn't being communicated, and I'm going to go into Renoise, and Renoise handles it just fine. So this is how the arpeggio should have sounded. First I've just got to load an XM file. So this is how it should have sounded. Whoops. Oh. Well, I have like all these different settings for the arpeggiator, but you see how it's actually coming out on this one, although it still sounds shitty. That's a problem with the arpeggiator right now. Not really the arpeggiator, but like the sound that I'm using. You know, let me see if I can find a better one. So that was a better example. And if we go out of Renoise and we go back into this, we'll see it's just awful. I have to turn the octave down. You see how we miss some notes? And that sometimes there's like this sort of delay latency thing. So I think that has to do with the external APU API thing that I'm using, you know, which I've opened up manually. And not only that, I noticed that there was an improvement if I didn't use key off commands, which, you know, write to the SPC DSP to do the key off. But you're supposed to use the key off to eliminate clicks in the audio. But I noticed this funny thing where if I actually go in and if I disable, like the key off, if I actually don't key off, I remember this sounding better. So let's test that out. What's going on? So this won't use key offs. By the way, I'm just going to say it compiled brr.cpp, which insinuates that I made a change to that file. So I don't remember, you know, but whatever. No. Where's STD, yo? Is this the one? Must be the next song. It would also be cool to be able to, when you have this soloed, if the thing would solo down here. Because I don't know which sample that is. But it doesn't matter, you can just go to the instrument and we can start playing with that manually. Oh, and via the MIDI keyboard we can actually scroll through the voices. Check that out. So I'm going to do the arpeggiator. So I don't know, it still sounded kind of crappy, at least rhythmically. Melodically, there was less notes missing, which tells me that there's some sort of issue with the key off happening from the external API, and I don't really know enough about doing it properly, like from an SPC program. But once I start creating the tracker and the driver program to actually, you know, do this stuff, I'll be better prepared to handle this situation. But more importantly, I mean, I'm not trying to do this sort of high high-speed MIDI communication with the SPC. That's not what the SPC was designed to do. It was designed to run an assembly program. So this is more like a bonus feature that we have that we can even do this. Um, so I think that, I can still play with it. I don't have to have the arpeggiator on this high-speed crap, but I can still play. And being able to play with my keyboard, it can facilitate the actual development of the song, when you're just laying out notes on the tracker editor or the piano roll. And that's probably the extent that that MIDI feature will be. And also you can change the voice with the MIDI keyboard. And I'll probably add in some other features as I go along, and as a musician, determine what would be cool and feel good and make me feel like I can work faster and less hassle. So I don't know. That's basically everything I want to talk about. You can also use your PC keyboard, which I explained in another video, and you do it the same way all the trackers do it. The way the keys are orchestrated. For instance, the Z key is the octave that you specify here. So C4, play C3, and then it just kind of, you look at it like a keyboard. You can really go to some tutorial or something to find a. I wish I had a link, but I don't. But maybe Renoise, they'll show you how the keyboard's laid out, and that's exactly how it's laid out in my app, and how it's laid out in other trackers as well. It's pretty universal. Okay, and that was all with the PC keyboard, so it gives you a good range. Alright, I'm out. Peace out, guys.